Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. I will be covering these topics in these grades, not in this particular order. I am going to endeavor to get everybody ready for the nearest exams, but by the end of the year, everything will have been covered on multiple levels. We are going to look at compound angles from the Matric Trig syllabus. Here are your 4 formulas, and we're going to learn how to go from the compound angle to single angles and vice versa, from single angles on the right back to the compound angle. Right, so evaluate, and we're going to go from the compound angle of sine x plus 60. We are going to make that we're going to break the compound up into single angles. The pattern is sine the first, cos the second, plus cos the first, sine the second. And then we have special angles, so cos of 60 is a half sine x, and sine of 60 is root 3 on 2 cos x. And if we put that on an LCD of 2, we will get sine x plus root 3 cos x. Right, and that's it. Done. Let's do another example. Number 2 is going to be cos of alpha minus 60. Cos of alpha minus 60. Right, that is the cos of 2 angles subtracted, so it is this one on the bottom right. So it's going to be cos the first, cos the second. Change your sign. Sine the first, sine the second. Again, we have special angles. Cos of 60 is a half cos alpha, and then plus sine of 60 is root 3 on 2 sine alpha, and once again just get an LCD of 2 and you will get cos alpha plus root 3 sine alpha. Right, so there are plenty of these that they can give you, and I would suggest that you go and find some and practice. Right, now we're going to do the opposite direction. I'm going to give you the compounded version, and you're going to put it back into a compound angle. So it will say simplify. Right. Okay, these are a little bit more complicated. So cos 2 theta cos theta minus sine 2 theta sine theta. Right, this goes cos cos, sine sine, so it is cos with a plus sign, and it will then be 2 theta plus theta, which is cos of 3 theta. While I'm at it, I need to point out to you, if it's got a minus for the cos, then it has got pluses in the formula, and vice versa. If it's got a minus in the expansion, then it's got a plus in your compound angle. Right, number 2 is going to be sine 10 cos 50, sine 10 cos 50 plus sine 50 cos 10. If you look at that, it's not in a very nice order, so some of you will deal with that, but I'm going to go and write sine 10 cos 50 and then I'm going to write the cos 10 and the sine 50. All I've done is reverse these two, and considering they multiplied, it doesn't make any difference to the sine, it stays a plus. So now I've got the perfect pattern. Sine cos plus cos sine is sine of 10 plus 50, which is sine of 60, which is root 3 on 2. Right, let's go and put all those equal signs in. Right, the third question is sine of 15 cos of 60 minus cos of 15 sine of 60. Right, this one is going sine, cos, cos, sine, 1560, 1560. So it is in the correct order, but this one has a bit of a problem. What you know is it is going to be sine, because it goes sine, cos, cos, sine, and it's going to pick up a minus. But now this is the tricky part. 15 and then the 60. And that is going to give you sine of negative 45, which is negative sine of 45, which is negative root 2 on 2. Right, so sorry about running out of space. Let's put our degree signs in, and then I need to explain something to you. First of all, it takes all four of these, all four, to make that. And here again, it takes all four of these to make that. And here again, so I'm not going to keep circling it. Here the very important thing is that if you are doing the sine with the subtraction, then you need to be very, very careful. A sine with the subtraction must do the first one minus the second one. The order is very important, because otherwise you are going to miss this minus sign here, and then that minus sign, and then that minus sign. Something else I want to explain, just as a quick shortcut, is if you have a Cartesian plane and you have 45 degrees, that would go from 0 degrees up to 45 degrees. If you were going in the opposite direction with 45 degrees, that would be negative 45. Negative 45 lands us in the fourth quadrant. That is why this negative here is going to pick up a minus, because sine in the fourth is negative. Right, so let's squeeze in the fourth there. Right, on to the next question, which is question number 4. Question number 4 is cos of 350, cos of 80, minus sine of 170, and sine of 80. Right, so cos, cos, sine, sine, that's good, but we do have an angle that is not in the first quadrant there and there. So I'm going to reduce them using the cos diagram. So 350 is cos in the fourth, so we have to use 360 minus 10. And here sine of 170 is in the second, so it's 180 minus 10. Right, let's go back and fill in the cos of 80 and the minus and the sine of 80. Right, a lot of you do this in your heads. Your teachers don't really give you marks for this. They expect you to be able to go straight into cos in the fourth is positive. And then the cos 80 we leave. And then sine in the second is positive, so we don't change that. Sine 10, sine 80. Right, so we've got cos, cos, sine, sine. Everything is an acute angle. So that's just going to be cos of. If it's got a minus, it becomes a plus, and 10 plus 80 gives me the cos of 90, and the cos of 90 is 0, not 0 degrees, 0. Right, okay. That's number 4, and finally number 5. Number 5 I'm going to squeeze right across because it is quite wide. So that's going to be sine of negative 15 cos of 420 minus cos of negative 165 and cos of negative 690. All right, first I would say we've just learnt about sine of an acute angle is sine in the fourth quadrant, so it's negative sine of 15 times by 420 is not in your circle, so throw away a revolution and you will get cos of 60 minus cos of negative 165, you will add a revolution, so that will become cos of 195. And then cos of negative 690, you'd have to add 2 revolutions, 720, and you'll end up with cos of 30. Right. So before I carry on, I need to go back and sort out this angle that's not in the first quadrant. So that's going to be minus sine of 15 cos of 60. 195 is in the third quadrant, 180 plus 15, and then cos of 30. Right, which then gives us negative sine of 15 cos of 60. Don't be tempted to change that to a special angle, otherwise you're going to be stuck with what to do with the 15s later on. Minus cos in the third is negative, so that now becomes a plus cos 15 cos 30. Right, we do not have a formula that goes sine cos, cos cos. We have sine cos, cos sine. So I'm going to take this cos of 30 and I'm going to change cos of 30 into sine of 60 using co-functions. Right, so that's going to give us negative sine of 15 cos of 60 plus cos of 15 sine of 60. Then here again, there's a couple of ways of doing it. I'm just going to take out a negative sign to get the perfect sine pattern. So take out a negative, you're left with sine 15 cos 60. change that to a negative because you're taking out a common negative, and that will then be cos 15 sine 60, which is negative. Sine 15 cos 16 minus cos 15 sine 16 is sine with a negative inside, and that's going to give me 15 minus 60, which gives me a sine of negative 45, which brings that negative out because sine in the fourth quadrant is negative, times that negative is a positive, sine of 45 degrees, which equals root 2 on 2. Right, so let's just pick up again. The sine of a negative 15 is in the fourth quadrant. That's why it does pick up a minus. And I changed my cos 30 to a sine of 60 as a cofunction. And then I had the perfect pattern, but the perfect pattern with a minus here means that we must do the correct order of the 15 minus the 60. So the order is important because that then picks up a minus, and that minus then is fourth quadrant, comes out and multiplies by that. So let's just write in fourth quadrant for that, and the 2 multiply together, giving us sine of 45, which gives us root 2 on 2. So that is really pretty much as hard as it gets with negative revolutions, positive revolutions, and working with the pattern. You'll find the more you work with them, the better and quicker you see it, and then it'll all be behind you. Right, I hope you have learned something today, and so we will see you at the next. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.